Next one is Konrad. He managed to squeeze in the full talk into 10-minute slot about precompiled bundle scripts from content packages. So just let me reset my counter. 3 minutes would be too less, I think. So go ahead.
Yeah, perfect. I guess you can hear me this time. I had troubles unmuting my microphone. Yeah, thank you. So I'm going to talk about precompiled bundle scripts. So this is not a new topic. Actually, Radu and Karl talked about that the last two adaptTos. So they're interesting talks. But what is actually new is that you can generate them from content packages natively. So let's quickly wrap up what the advantages are. So the advantages of using precompiled bundle scripts instead of regular resource scripts is that you can detect the errors much earlier, so during compile time already. There's a much improved class loading. If you have a closer look at the class loader, which is being used by resource scripts, then you see there is a lot of things going on actually, and that there's a lot of overhead actually going on. And if you can bring it back to regular OSGI class loading, that simplifies a lot of things. So for example, what you gain automatically is explicit dependencies. There's the full support of version ranges, so you can explicitly state, okay, which Java package version I'm interested in, I'm supporting. And also there is support for easier resource type versioning. Precompiled bundle scripts are packaged in a more or less regular OSGI bundle, but that OSGI bundle that contains, first of all, obviously the Java servlet classes, which are the precompiled version of your scripts. Then the regular OSGI bundle metadata as every other bundle, and on top of that, some additional metadata, which is specifically there for your bundled scripts, basically. And the last part is eased with, basically, there's a Maven plugin supports generation of that metadata. There was still a missing piece until recently, and that missing piece is that AEM components are not scripts only. They consisting out of scripts which should end up in the bundle. They are also consisting out of of dialog definitions, which are supposed to end up in the content package, and they also contain the component definition, which states, for example, what is the resource super type, and also some additional meta information like a title and a description of the component. And this is partly necessary for the bundle, but it's also necessary to have available in the resource resolver or the underlying repository. So the problem was always that separating components, in this case I'm talking about AEM components over multiple Maven modules, violates the principle of low coupling and high cohesion. So, and the solution Radu came up with recently is that you build basically both the content package and the bundle from the same Maven module. Before we have a closer look at what that looks like exactly, let me remind you quickly of the capabilities which are necessary for dealing with bundled scripts. So the capability is named sling.servlet, and basically it comes with some additional attributes which explicitly specify the regular things which you usually register for a servlet or a script, like, for example, which extension should be handled, whether there are particular selectors required for your script to kick in, and things like that. So basically, you have to provide always two things usually. So first of all, there is a require capability because usually your components are not standalone. That means they inherit from some other resource type, and that resource type should be mentioned in the require capability for OSGI to be able to wire up the necessary bundles basically, and to make it more visible and more explicit so you can easily detect if some dependent bundle is deployed or not. So the require capability is necessary for the resource supertype and also for all the references which you might use inside HTL. That means you're using the statement data sli use. What is new is that this is now being generated from FileVault doc view properties. One property is used for other purposes as well. So you usually have that already, which is sling resource supertype. You use that already for formulating an inheritance. And the other one is a new property, but it doesn't do any harm if you add that to your existing components. And that one is named sling required resource types. You can give multiple ones, and the idea is that out of those property values, the required capability values are automatically generated. In addition, basically, you have to provide the capabilities for all the servlet your bundle provides. So for all the scripts, basically, which you include in your bundle, you should have an according sling servlet capability provided. Also, this one is being automatically generated because it can be determined from the script location, because the script location determines which resource type it is registered to, basically. Sorry for this. This might look a little bit complicated, but I guess this is mostly due to my disability to come up with a proper graph here. So what I want to say here is basically that out of the same Maven module, you generate two different artifacts. So on the left-hand side, you have the primary artifact, which is still the content package without any classifier. And that goes the regular way, meaning that you first generate the metadata with a FileVault package Maven plugin. And that metadata is then being packed together with basically all your source files in the relevant source directory into a content package. What is new is a part on the right-hand side where you generate an OSGI bundle from the same source. So you take the source and you give it to the HTL Maven plugin, which will pre-compile your HTL scripts into Java servlets. And those Java servlets are then compiled into Java classes, and those classes are then being processed by the BND Maven plugin. BND process goal, which takes care of generating all the bundle metadata. There's one plugin for that, which is the scripting bundle Maven plugin. So despite the name, this cannot only be used as a standalone Maven plugin, but also as a BND plugin. And this one acts not on the classes actually, but on the source files directly to figure out the capabilities to generate basically the sling servlet capabilities. Everything ends up basically in the manifest, and that manifest is packaged together with the classes, the servlet classes, and the Maven jar plugin is then packaging that everything up in the resulting jar file. And that jar file is having a dedicated classifier called precompiled script. So if you run a regular Maven clean package, for example, on your Maven module, what you get is two different artifacts out of that. So one is a content package and the other one the OSGI bundle. Oh, I have to hurry up a bit. So let's quickly see whether I can quickly give you a demo. So Radu came up with an integration test in Sling. So I will link that later on. And basically what you can see in here, let's start with the POM quickly. What you can see in here is that this content package, so let's start with the packaging. The packaging is still content package. So the primary artifact is still the package itself. This one is generated with a firewall package Maven plugin. In this case, the package is mixed, but you can cleanly separate between mutable and immutable. And in addition, what is a little bit weird is that you do have the BND Maven plugin inside there as well, with the plugin which is the scripting Maven plugin. So this one is generating the metadata for the OCI bundle. And if you run that, and I'm running out of time actually, you get 2 different artifacts here. And Stefan, yeah, I guess that's all. There's 2 more slides, but you can look that up on your own, basically. I hope you got the idea. Thanks a lot.
This was great. Thanks.